Yes, when we say rate of chemical reaction, rate of chemical reaction is just telling us something very unique about the chemical reaction. So I'm going to be introducing you in this video by giving you definitions to some stuff you're supposed to understand and go to rate expression, then rate law very briefly. So when you hear what is rate of chemical reactions, it can also be called velocity of reaction. It is just talking about, whenever you see the time rate, the word rate, you must think of time. So rate of chemical reaction is just telling you how the reaction proceed, how fast the reaction proceed, and what happens with time. And you know that reactants are the first reactant species, and reactants must decrease for product to increase. So rate of chemical reaction is just the measurement of the decrease of the reactant to favor the increase of the product per unit time. So if you said reactants decrease and products increase and you did not put the word per unit time, you have not defined rate of chemical reaction, because anything that have to do with rate must have time. That's why when they say divine velocity, they will say velocity is the rate of change of displacement with time. So it is that time that makes it rate of chemical reaction. So in chemical reactions, when you study how reactants decrease to give us products, and the product will increase in contrasting manner. So it means rate of chemical reaction. I hope you understand that. Now, what is rate law? Rate law is just a mathematical expression that shows the relationship between it is. Please note, it is a relationship. Rate law is a relationship and is a mathematical expression that shows the relationship between the rate and the concentration of the reactant with respect to their order of reaction. When time goes on, when I get to this third point, I will go deeper into rate law. What is rate expression? Rate expression is just a symbolical way of showing the rate of decrease or increase of reactant or product respectively. Then what is order of reaction? Order of reaction is the respect of concentration of the reactant species. But let me try to point out something. In rate law only depends on the reactants, as we know that reactants are the most important species in a chemical reaction, because without them, the reaction cannot proceed. They are the life or the starter of any chemical reaction. And the order of reaction should not be mixed up with the stoichiometric ratio of any reaction. Let's say, for instance, A molecule of A plus B molecule of B give us C molecule of C and D molecule of V. The A, B, C are the stoichiometry, that's the coefficient, while A, B, C, D are the element. So these A, B, C, D are not the order of reaction. So you have to calculate for order of chemical reaction. So I'm going to teach you when time comes. Now, rate expression and rate law is the next session I'm going to be taking you through. So let's start with rate expression. I've already told you that rate expression is just a symbolic representation of that we use to show the rate of decrease or increase of reacting species. So because A and B are reactants, so it means that whenever you are expressing them, you have to express the concentration of change in A divided by change in time. Time is very important in rate, but this minus sign is indicating that they are reactant, because reactants must decrease. So you now notice that both A and B, because they are reactant, they carry negative sign. So this curly brace is very important. You have to put this curly brace because it shows concentration, and this delta means change is very important. But the product side, C and D, you see that in the rate expression, I did not put a minus. It shows that they are products. So when you see a rate expression and there's no minus, it means that that particular species is a product. I hope you understand. So finally, I'm now going to go to what I called rate law. Rate law is a law that shows the relationship between the rate and the concentration of the reactant. Rate law depends only on the reactant, because rate law assumes that the reactant are the only important species in a chemical reaction, because without them, the reaction cannot proceed forward. Then these are the elements of rate law. K means rate constant. N means order of reaction. That means the reactant will be rate power of the order. While R means rate. So the mathematical expression that relates rate R to the reactants, to the concentration of the reactant, is known as rate law. So for instance, if they give you a particular equation like this, A molecule of A, you have this B molecule of B to give C molecule of C plus D molecule of D. So this is the rate expression. You are going to say rate equals to K. K is a constant, it must be there. Concentration of molecule A, because it's a reactant, raised power of M. M is the order of reaction, which is different from A. So A is just the coefficient of the element in the equation. So M, there's a way you have to calculate for it. In subsequent video, I will show you how to calculate for order of reaction. And then I don't want it to be equal, that's why I use another letter here. So order of reaction has to be calculated for. It's not the same as the stoichiometric ratio. Now, so and then it only depends on the reactant. That means, for instance, let's say H2 reacts with O2 to give us H2O, H2O2, and they tell you to express the rate law. How do you express it? The rate law will be R equals to K into H2 raised power of M and into O2 raised power of N. So you will see that the coefficient of AZ, that means my A for hydrogen is 1 because there's no number here, and my B for oxygen is also 1. So I will have put 1 here. That's first order reaction. But this stoichiometric ratio, the coefficient of the element in the equation, is not the order of reaction. So there's a formula for calculating that. So just be familiar with this. The rate law equals to K into reactant raised power of order of reaction. So N means order of reaction. Thank you.